Hey everyone, in this video I'm going to talk about some of the AI functions that have actually been released by Google BigQuery recently. So if you are into MarTech or marketing analytics, or if your team is using it, you must be using BigQuery. And BigQuery is obviously your data warehouse. You can do tons of stuff there, but increasingly Google is actually integrating analytical aspects within BigQuery as well, so that, for instance, you can actually now do forecasting. So AI.forecast, so this is within the reference documents. As you can see, the help documents, and you see that this is within this area here on the left hand side menu. It's under the generative AI functions and work within time series. So work with time series. So AI.forecast, and then there is AI.EVALUATE, and then there is AI detect anomalies. These are the three different AI functions that have actually been released recently by BigQuery. And in fact, within that, AI detect anomalies is still kind of in a beta phase, so they will have limited support, but nonetheless it's still working. So this document has got all the different ways of working with it. I'll actually talk about a specific example. It has some example queries as well. So I will actually just jump onto my Google Doc, and I will walk through what these are, and how it actually relates to your forecasting activities and other stuff. So in this document, which I will also link in the description, first of all, I will talk about a bit of a background. And so this is, what does it mean by AI? So it means that you can now completely bypass the manual coding, or sort of using Python packages to do forecasting. So you don't have to model it from scratch anymore. You don't have to do any kind of forecasting, because anomaly detection, by the way, for instance, which is the latest one, detection of anomalies, AI dot detect underscore anomalies function in BigQuery. This is, just within a small piece of SQL code, you can actually execute it. But in general, what happens is you will have to run like a full scale model, and there are different approaches to it. So there are some approaches that I've listed here, like ADTK. This is very popular. I'm not going through all the links. You can just check them out. This is actually specifically for anomaly detection. That's what AD actually stands for. And then you have a collection of several packages under this alibi detect, which is actually from PYPI. And then you also have the STL lowest, STL, which is the decomposition lowest, which is your which is your smoothing, or smoothing technique. And you have LSTM, which is a more deep learning, or neural network kind of an approach, which is given by PyCharm. You can actually check out this blog for the entire code base for that. Then you also have Merillion, which is by Salesforce. You have Stumpy, you have PYOD. Facebook Research Cats is also very good. It's a dedicated anomaly detection and also forecasting model. So there are so many other existing approaches, and I'm only talking about the dedicated packages here. You can obviously set up from scratch anomaly detection code as well, using Python or any other language that you might be working with for data science. So these are things that are now legacy in a sense, because these are the ones which have been used all this while. But now you can go ahead and within BigQuery itself actually do all of these things without having to do the manual model building. That's the whole idea of these new AI functions. So basically, what AI is doing is that it's doing the work of a data scientist, doing the work of data science in general, and it's kind of automating this process without you having to do these from scratch. Obviously, there's going to be a lot of talk about these models, and these models, by the way, are called foundational models. So you might be wondering, like, how do they actually work? Like, they obviously have a lot of pre-built code base, like how they're going to work, and they are using something called a TimesFM model. Okay. And I have opened given a couple of links here. I'm going to actually go through the concepts anyway in this document. So this is all part of BigQuery ML. That's how it features in this entire thing. And within BigQuery ML, you also have this TimesFM model, which is specifically times forecasting model. So you do get forecasting related things that you can do with this model, and within that you actually have these AI functions as well. So it's basically, the AI functions are using TimesFM model. So if I just jump into this diagram here, you will see that this is the concept that's being used by TimesFM model. So what it does is it uses something called transformer, and its mechanism called causal self attention. So self attention is a kind of attention mechanism, which is a way how the transformer architecture actually works. The transformer is ultimately a concept within neural networks. So it's a kind of architecture using neural networks, perceptrons, how how basically different kinds of things like like classification can be done, image classification and other things. And in this case, to sort of understand, read, and to sort of understand and decode data, which is why it's actually called a decoder only. So if I move into this section here, you'll see that TimesFM is nothing but a decoder only foundation model. A lot of other models actually in the transformer space use the encoder decoder architecture, but this one uses only decoder. I'm not going to break down all of these things, but just to give you an idea that this is how it is like based really, and like how what is the structural foundation of this model, which is ultimately the or one which is getting used by these AI functions. And then you have it's actually a pre-trained model. So apart from the fact that its architecture is based on transformers, it is also pre-trained with 200 million parameters. It is based on a lot of forecasting data across diverse data sets. So it's learned from different things. So it's very much so, that's why it's kind of like Gen AI. So you'll see that it's not kind of, but it is Gen AI. So it's basically not just automating the modeling process, but it also has a prior information. It has also got prior training from a lot of data sets across different sectors. And so the idea, and this is basically the concept of foundation models, and I will be talking more and more about foundation models. Of course, I'm learning about them myself, and of course it's a relatively new concept, at least in the industry, and certainly in marketing. So this is going to be talked about more and more, and I'm going to talk about it more as to what its benefits are, and what its possible limitations could be. So what are its key capabilities? So it's a zero shot forecasting, you can say, in a sense that no training is required, flexible context and horizon lens. Horizon is meant that by that is meant like what is the length of the forecast essentially. Then you also have multiple granularities. It handles hourly, daily, weekly, monthly data. Competitive accuracy, at least that's the claim, that it achieves near state of the art performance compared to supervised models trained specifically for individual data sets. So it's actually been claimed that it's very close to ARIMA or autoregressive group of models, in terms of its performance, criteria. In fact, it's very very similar to autoregressive models. We'll actually see in a moment. So how it works, we'll see it right now. So and again, we are talking about TimesFM model. So we are talking about the model which is used by these AI functions for forecasting, evaluation, and for anomaly detection. Okay. So Times FM basically chops the series into pieces. So first of all, think of a time series. So a normal, if you were to do a forecasting exercise, or an evaluation of the forecasting model, and then the detection of anomalies, you would be starting with the time series data, right? So it will have a date column, for instance, and instead of therefore taking a daily date points, or whatever is the granular level of the granularity level of the time um, component of the different rows, you will be chopping it into different pieces, and then you will be putting them together into things called patches. That's how basically this works. So these are like so chunks of different data points which are taken together like tokens. So you can compare it with the NLP process, natural language processing, which is where you use the concepts of tokens. So it's very similar. So you use different patches, as you can see, different numbers of points here within each of these patches. Next, you will basically be converting them, each of these patches, to a meaning vector. Again, very similar and comparable to NLP. You might understand if you have some idea about NLP, where you create some vector databases based on these, based on so after converting everything into numbers, text into numbers. So then convert each of these into meaning vectors, and then compare all the patches to learn relationships. Okay, and this is where your self attention mechanism comes into the picture, because you're trying to understand its relationship with the other elements, right? And this is where basically the understanding about seasonality, trend shifts, and curve shapes come into the picture. And then finally you will assign, they will use the last meaning vector, the recent one as well. You will put more emphasis onto it to do a forecasting into the horizon. Like I said, so the horizon is going to be the data points in the future that this model is going to forecast for. All of these can be tweaked, of course, if you're doing modeling manually, and you can do a certain level of manual modeling even with TimesFM. We are going to come to that, but let's understand, like, what is the kind of data points that has been trained on. And this is actually going to be a very, very important talking point. And again, I'm also going to talk about it because, like, what makes a foundation model a good model and better, right? So the claim is that since it has learned from lots and lots of historical information, like other data sets from across diverse sectors, that it's inherently better than a model which is not pre-trained, and it's only being guided by the intelligence of the data scientist currently using it. So the data points that has been trained on are Google Trends and Wikipedia page views and synthetic data. So you can see the number of time points here, like really large number of time points. A huge amount of data basically. So ARMA processes synthetic data. It's also trained on synthetic data and also public data sets. So these are very useful training information, like there's no doubt about it. It's been trained on pretty rich data, and it's also got a data mixing of around, say, 80% real data and 20% synthetic. So a lot of real world data it's been trained on. So it has got good training, but whether it's going to be overfitting to that, or whether it's going to underfit, or it's not going to understand new things as well, because even with all that information, it may not be capable of dealing with new things. We don't know. That's what is going to be what's going to be found out, I think, as people adopt this more and more in the coming days. But definitely something that we cannot ignore, the concept of foundation models, of which TimesFM is an example. And so creating a TimesFM model, there's a piece of code here. These are the parameters that you have to talk about. The model type being TimesFM. Then you have a timestamp column. Then you have a time series data column, of course, which is where you put in the values. And then you have a time series ID. This is specifically for multiple time series. You can also have multiple time series. Therefore, you give an ID for each of the time series individually. And then you just do some basic querying. And again, I mean, I'm just going through, I'm kind of rushing through it, you might feel, but of course I don't want to make this video too long. And I just want to give you a quick overview, and then you can make predictions by using ML forecast. So like I said, this is ultimately part of BigQuery ML. So you can use TimesFM using BigQuery ML directly, or you can use the AI functions. Um, so the difference between those two, by the way, just to give a quick overview, is that it's more customizable when you're using BigQuery ML. Okay, so you can use hyperparameter tuning and stuff like that. Those will be available to you. But when you're using the AI functions, it's a completely pre-built package for you. Like it's like a switch. You just turn it on, and yeah, it's going to do its thing. So what are its key features? Like automatic pre-processing, flexible horizon. So like I was saying, like it's essentially going to decide for you know how much for what specific data points into the future that it's going to forecast for, and it auto regressively generates predictions for long horizons. Okay, so that's what I was saying, like it uses auto regression because it's going to do forecasting on the basis of past data points as well. So that's basically your concept of auto regression. And then it can also handle multiple time series, like I just mentioned. um, you also have the option to fine tune hyperparameters. So you have model type, and we already talked about a few things. You can also have the frequency, uh, where you can define the granularity level as well. um, so yeah, there are some differences with traditional statistical methods and supervised deep learning, and you also have differences from basic LLM based forecasting. So you can take a look at that as well. Like there's going to be differences with respect to the use of manual versus automated parameters, or how they handle complexity or the time taken. So there can be some differences which can be talked about. Now I've also given the AI forecast as well as AI evaluate and AI detect anomaly queries. And if I'm not going to walk through the query. I mean, there's no point. You can just use those. And this is a query which has been used on the GA4 e-commerce data set, by the way, and when I was trying to forecast for a horizon of, I think, 10 days. if I'm not wrong. Yeah, so the horizon of 2 weeks, actually horizon of 14. And you can see how this is using the AI.forecast here in this part. Very simple. It's casting the purchases as float. And yeah, therefore that's what it is. So the way this query has been written actually is basically where the entire table is not going to be outputted. Like, it's not going to show you all the data points, including the historical data points as well as the future forecasted values. It's actually going to give you only the output in terms of the table. So this is where I can show you this screenshot a little bit more, and this is the output of this exercise. And you will notice that here what's really going on is basically, you have a line chart which shows the date, of course, on the x-axis, and all the values, right? The actual predicted, and the intervals, right? Upper and lower thresholds. So all of these have been actually plotted, and you'll see that how this actually varies over time. So actual versus predicted, the legend has been shown here, but it's visible within BigQuery itself. So I've just taken a screenshot so as not to sort of cause any lagging issues during the making of the video. But the point is that you can easily visualize it. So this visualization function is also available, so you can check which how the actual versus predicted is doing. From my experience, after doing the forecasting, and actually after running the evaluation also, like in this query itself, you'll see that there was an error that was being calculated even without this AI.evaluate. So this query itself, the query that has been used here, actually does calculate the absolute error and the absolute percentage error. Okay. So that's something you can do, and it came to be somewhere around in between 10 to 15% on an average, which is not bad actually. But it did go up close to 20%, and it was a 10-day forecast, remember. The AI.evaluate is specifically for evaluating. And here also we found, in fact, in this case, we found that the error rates were kind of between 15 to 20% as well. um so it depends, like what kind of error percentages that you are choosing. That of course makes a difference. So it was again on the same data set. You'll see, there you go, GA4 of cascaded sample e-commerce events. Um, so the last one is the anomaly detect query with the flag. So there's an example which has actually been given in BigQuery's documentation, which tells you um, how actually which gives a sample query, and it shows you how you can use this evaluate query, or rather, sorry, this anomaly detection query. I just tweaked it a little bit, because in that one you could only plot the probability of anomaly, like what is the probability of anomaly, but whether or not. So the flag, there's called there's a parameter called is anomaly. So that particular one actually cannot be plotted, because it was in because it was in true or false. It was boolean, but I changed it to binary, but just by just using one line. So one line of query can actually sometimes change things so much. So this particular one here, case when is anomaly. So you see, that's what I plotted here. So I've plotted the anomaly probability and the anomaly flag together this time, instead of what was originally. And you can see that you can only look at these two for this particular model. They have chosen these 2 points as anomalies. So now the question comes is whether or not this is a good anomaly detection in the first place. That's a question to ask, because if you look at this visualization here, you'll see there are 2 3 points at least which are fairly close to these two. Of course they're higher, so I'll you know give it to it. And you will have to probably decide also, like what's your upper bound and what's your lower bound. So that's something that has to be also figured out. I have to check also, what are the parameters for that. But I think, like in and of itself, if you just use without looking to customize the code, uh, it might not give you the best results, because to be honest, it has to be a very good definition of an anomaly for it to be called an anomaly, right? It should really have a good threshold definition. Now let's actually compare quickly the features, like how it compares with the different models. So like I already mentioned, that this is using the concept of TimesFM is using the concept of feature transformers, which is basically linked to deep learning, which is linked to neural networks. So within neural networks you will have deep learning, within that you will have transformer, which is a kind of architecture, and within that you have you have its components, which are encoder, decoder. In this case it's only decoder. And then you also have a mechanism, which is attention mechanism, in this case self attention mechanism. So that's how the entire thing actually operates. And on the basis of these mechanisms, on the basis of how it actually works, so you can just look into this diagram, which just explains this internal logic without going into all the perceptron and all the neural network math. There's a lot of mathematical concepts involved, but it's important to understand this, because otherwise you will not know whether or not you are using the model in the right fashion. So the forecasting capabilities, I have also given the table here, which classifies the different approaches that I spoke about at upfront, and I compare them with TimesFM. So you can see that auto seasonality is there, and it has any it has the horizon flexibility. Not everything has horizon flexibility. They will have, some of them are configurable, in other cases they might not necessarily be. um, of course with STL it's a fairly configurable model, but the problem is that if you actually try to focus too much into the future, it's going to start giving you really bad results. And then you also have its primary purpose being forecasting. So it's specifically, its objective is to help with forecasting activities and other related activities as well. And data requirements, this is also very important. I'm not going to walk through every aspect of it, but I think the overall point is that it should have, it does not require you to actually impute data. So it has imputation capabilities on its own. It handles irregular sampling, it handles multiple granularities, and pre-processing is not that much required. So that's the whole point about it. If you look at some of the other ones, either they are dependent on specific methods, or they require some pre-processing in many of the cases as well. So I think the main point here is that is that it is aimed to that it's aiming to reduce effort, that it's aiming to reduce the onus of really getting good results on the data scientist. The data scientist is just going to become just going to be freed up from a lot of manual data processing. That's the idea behind it. And because the model is also pre-trained on a lot of real world data as well as synthetic data, the idea is also that the model output is also going to be very good, the forecast is going to be of good quality. But I think that's something that time will tell. I think it's still too early to say if foundation models like TimesFM are they're definitely here to stay, but whether or not they're going to be fully be able to substitute or replace models which are which are done manually, or which are built up from scratch, from the ground level up, or even some of these packages which sort of implement these different modeling approaches. I think that's something that only time will tell. We still have to wait and see if that's really going to happen. But yeah, expect some content around that as well from me. But do let me know if you've started using it, if you have got any experience already that you want to share. Do let me know in the comments for any of these functions in BigQuery. If you have applied it in your data sets, I'll be really interested in knowing that experience and having a conversation around that. But that's it for this video. And yeah, thanks for watching, and I'll see you in the next one.